All right, ladies and gentlemen, welcome to geometry. If this is period 3-4 and you were here in class on Friday, you can probably skip this one. Some of the classes got to this, some did not. You were asked for homework. Period 3-4, you've already done this, you had no homework. So skip to this, go to part 2. Go to part 2 of this video. Period 5-6 was asked to make these 5 conjectures. So when you're at home, take a ruler, take a protractor, measure stuff. Hopefully you came up with 5 things. There may not be the same things I have, but I'll talk about them right now. One of those things, and I gave you some words to try to use, is that opposite sides are parallel. So these are parallel, and these are parallel. That's one of the 5 things. Another thing is the opposite sides are congruent. And if you want to write these down real quick in your own words, you can do that. But those are the 2 big ones to start with. A parallelogram, the definition of a parallelogram is opposite sides are parallel. And you got to have 2 pairs, not just 1 pair, because it could be a trapezoid if you only had 1 pair. So we're not going to prove that opposite sides are parallel. We're going to prove some other things. We're going to prove opposite sides are congruent. Those are the same length. There's another thing about opposites on here, which you may have discovered. These 2 obtuse angles are also congruent. The opposite angles are congruent. So that means these acute angles are congruent and also these obtuse angles. There's number 3 of the 5. Number 4 is something about something you already know because of parallel lines. Think about what we call these 2 angles. And I gave you a vocab word on your paper for them that you've never really seen before. Next week you might hear about Seahawks winning consecutive Super Bowl championships. Consecutive means one after another. So in other words, these 2 angles could be called consecutive angles. This could be like A, B, C, and D. That would be all being consecutive. If we talk about just 2 of them, we can say something about consecutive angles. They're certainly not equal. And hopefully you're going, oh, they're supplementary. Consecutive angles are supplementary. These 2 are supplementary, or I could say like these 2 are supplementary, or these 2. In other words, one's not adjacent to each other, but they're consecutive, one after another. Now, we had a former name for these. If these were parallel lines and you think of the transversal, these 2 angles are called same-side interiors. Consecutive angles of a parallelogram and same-side interiors are the same exact thing. We don't really have to prove that. We've already proven that same-side interiors are congruent. So we're just calling them consecutive angles. So that's number 4. So sides are parallel, sides are congruent, opposite angles are congruent. Number 3. Number 4 was consecutive angles are supplementary. The last one and the 5th one is hardest to see. If you haven't drawn the diagonals, draw in both of the diagonals. You got one here, a real long one, and I got a shorter one on my screen here. I got a shorter diagonal over here. So, and then if you haven't done that yet, pause it, look at it again, and try to come up with a discovery about the diagonals. And hopefully you spend a few minutes on this. The diagonals cut each other in half, and there's a vocab word for that. They cut each other in half. And most of you know, they bisect each other. So we're going to prove that in a few minutes. We're going to prove they bisect each other. Another conjecture that's not one of these 5 I mentioned that many classes came up with, the other classes, period 7-8 and period 3-4, was that congruent triangles are created by these diagonals. That's how we're going to prove this stuff. So we're going to create some congruent triangles in a moment. So here's the first proof on your paper. There's nothing given and there's nothing to prove yet because I wanted you to come up with those conjectures. We're going to prove some of those conjectures, some of those educated guesses. So maybe start with just labeling this thing parallelogram A, B, C, D. The given is that it's a parallelogram. And as soon as I say the word parallelogram, hopefully you know something you can write down that's given on here besides the word parallelogram. If I say it's a parallelogram, that means that it's got some parallel sides. Means AD is parallel to BC. That's a given because it's a parallelogram. And of course AB is parallel to DC because it's a parallelogram. So there's our given. The first one I want to prove is kind of an easy one, is that those sides are not only parallel but they're also congruent. And I just use an equal sign on there. You can use a congruent sign if you want instead. And I'm going to do that for both pairs. So I've got 2 pairs of parallel sides. I can prove that they're also congruent. If you look at this and you say, have I done this before? This is very similar to the proof that was on the midterm, I believe. I think it just switched this with that, so they're just reversed. So it might make a lot of sense as we go through this. So, Again, you look at that and you go, how the heck am I going to prove sides are congruent? Well, maybe you realize you're going to use CPCTC at some point, and to use CPCTC, you're going to have to prove triangles are congruent. Right now, we don't even have triangles. So the question often comes up, how do we get triangles? Well, we draw a diagonal in there, and you could draw either diagonal. I'm going to just draw BD. We only need one diagonal for this proof. And we're going to try to prove that these two triangles are congruent. So triangle A, let's see, ABD is congruent to the bottom one. If I say ABD, I better go with CDB, going the other way. So trying to prove those two triangles are congruent. I don't know what step that is. It's probably step 5, something like that. I'll leave myself some space. I'm going to work backwards from that. To prove the triangles are congruent, I need to have sides or angles that are congruent on here. And something obvious might jump out at you. Well, duh, the line you just drew on there, the segment you just drew, BD, is obviously congruent to itself. And of course, you can write down a reason for that. So we've got a side. Because of this, we've got some angles. You got that old Z shape that gives you alternate interior angles. You got this alternate interior angle is congruent to that alternate interior angle. And we have two sets of parallel lines, so we've also got this Z shape. This angle on this side congruent to that one. So take a minute, write down those alternate interior angles that you're going to show are parallel. Show are congruent. ADB is this top angle. Now you just name the bottom one down here. CBD. That's one pair. And then we got ABD. ABD, this angle, congruent to, go across to the Z, the other side, to CDB. Get two pairs of congruent angles on there. And of course we said Y a minute ago, the parallel lines give us alternate interior angles. So there's like step 1 in the proof, there's step 2, this might be step 3, triangles are congruent, step 4. Hopefully you can put these things together. If you mark that stuff, it'll be obvious why the triangles are congruent. You've got an angle, a shared side and an angle congruent to an angle, an angle, a shared side and an angle on there. So we got some angle, side, angle. I would also include the transformation. Is it a reflection? Is it a rotation? Or is it a translation? And I think it's pretty obvious it's a 180-degree rotation. I often like to ask, where is the rotation? Where's the center of the rotation? It's the midpoint of this diagonal. A is being rotated onto C, D is being rotated onto B through a 180-degree rotation. And of course, after we prove triangles are congruent, we can finish the proof off. We can now go say that these parts are congruent. If I look at the letter order, AB would be congruent to DC, or CD, DC. It's AB, CD. I should switch that around. I mean, not that it really matters, but that should be switched on there. And of course, the other one we're trying to prove was AD and BC. Also congruent. Maybe switch my letter order around here. And of course, that's because of they're congruent parts of the congruent triangles that we just proved were congruent. And I was about to move on, and when I was writing this slide, I said, wait a minute, we've proved something else. We just proved that opposite angles are congruent. So we just proved two things about parallelograms. Opposite sides are congruent, and the opposite angles are congruent because of CPCTC again. Those are parts of those triangles. And I'm not going to do angle B and D. We could do that. We would just have to redo this proof and draw the diagonal the other way. I think most of you can accept that, and we can go on to the second proof. Okay? So we'll move down to the second one in a moment. Start that in part 2.